All right, really quickly. Guys, listen up. Really quickly, I want to do a quick review over what we did right before lunch break, just so we have it as a recorded session. And then I'm going to kind of extend it a little bit, and then we'll get on our worksheet. I only have one class worksheet today. One new thing I want to start doing is this. So I'm going to start writing on the board in every class what thing we're going to do today and when it's due, so that you, if you would like to write that in your notes, you may, to kind of remind yourself what needs to be turned in and what doesn't need to be turned in. What needs to be turned in and what does need to be turned in, because we're having some forgetfulness, and I'm having kids who come up and go, I made like a 92 on this, but then there's 20 points deducted. Right, because it was 2 days late. Okay, so you can quickly take a very good grade and it become a not very good grade if you're not turning it in when you're supposed to turn it in. Yes, ma'am.
How do you have a 92 but you 14?
Because you turned it in 2 days late.
Wouldn't it be like 110 or 12?
No, you started with a 92. In other words, you actually made a 92, then I took away 20 points because you didn't turn it in on time, so all of a sudden it became a C minus. No. Okay, so today there's a class worksheet called Irrational Square Roots. Today there's a class worksheet called Irrational Square Roots. It is in the, it is online. And it says CW for classwork, so that's going to be due at the end of class. There's no homework, so I want y'all to make sure that you're done with your reviews when you walk in tomorrow. Okay, remember those reviews are due tomorrow. Okay? Do what? I haven't decided yet, but you need to remind them tomorrow. Okay? Any questions about what to do? Cool. So before we left for lunch, we were talking about irrational square roots. And if you'll remember, we have basically a list of irrational roots. We have a list of good square roots and bad square roots. Let's make our good square root list from the square root of 4 to the square root of 144. What's after square root of 4? 2. Wait, what's the good square root after square root of 4? 9. Square root of? 16. Square root of? 49. That is generally the list you will need to have memorized. That is generally the list you will need to have memorized. I will very, very, very rarely, or STAR test will very rarely ask you to approximate an irrational square root outside of that square root of 4 to square root of 144 window. Okay? So these are all of our list of good square roots, which means every square root not listed, every square root that's not listed, whose numbers between 4 and 144 is considered a bad square root, or again, an irrational square root. Who wants to give me that quick definition of what an irrational square root, what an irrational number is? Labib. What doesn't have, I want specific, say it again. It is a decimal that is infinite with no pattern. It is a never-ending decimal, Britton, let's stop that. It is a decimal that never ends and never establishes a pattern within that decimal part. Okay? So, let's start with, let's do the square root of 18. Now, what's step 1? We have the square root of 18. We know it's irrational, it's on the list. Jackson. What's in? Perfect. It's between the square roots of 16 and 25. That is step 1. Which means it's between what two whole numbers? Now look.
4 and 5.
It is between 4 and 5. We know it's between 4 and 5. Now, before I even write the decimal or the fraction, is it closer to a 4, or is it going to be closer to 5, do you think, and why? Jason? Closer to 4 because the square root of 18 is closer to the square root. Very good. So now we just need to know where it is. And in fact, guys, if you want to at this point, go ahead and write that it's going to be 4 and a fraction. You may do that, because it is. It's going to be 4 and a fraction, part over whole. we find the part and how do we find the whole, Jaden? How do we find the part and the whole? Perfect. We find out how far it is between 16 and 18. That is 2, so that is our part. Now the entire distance is from what to what?
It's from 16 to 25.
16 to 25, which is 9. That is our estimated irrational square root.
Are we required to turn it into a decimal?
That's a very good question. Jack said, are you required to turn it into a decimal? You are not, unless you're having to do some sort of an ordering process, right? So if you were to see the square root of 18 in this list of numbers you have to put in a particular order, you may have to do that, right? You may have to do that. So by the way, did we end up closer to 4 than 5?
Yep.
We did end up closer to 4 than 5. 4 and 2 9. 4 and 2 9.
Will all of these are 5?
Yes, automatically it will. That's a very good question. Yeah, it will always, well, she's saying, when you build the fraction, is it always pre-simplified? You see me shaking my head no.
Oh, I thought you were just...
No. No, I'm not having a seizure. I'm telling you to stop again. That's number 2. There's the book. Thank you. Okay, so it does end up automatically simplified. You don't have to simplify the fraction from there. How would I then turn it into a decimal? Yes?
Divide 2
divided by 9. But, does anyone know the trick of the ninths?
Yes.
Right, so this is really 4.2 repeating.
Oh, yeah, because if it's a 9, it's never...
If it's a ninth, that's how you turn any ninth into a decimal. 7 ninths is 0.7 repeating. 5 ninths is 5 repeating, 0.5 repeating. Every ninth is that number repeating over and over. Except for, no,
9 is 9 repeating.
one whole,
Except for everything about this. You can't.
with 0 repeating. Ah. Christopher.
Everything is repeating. But I thought you said that they can't, that they're always,
No.
endless decimals without a...
Christopher's exactly, Christopher said it, but this has a pattern, and you said they don't have a pattern. This is an estimation. This is not the exact number, and in fact, the only way to find exactly the square root of 18 is with a calculator. Because you can't just come up with a number that's endless and know that that times itself gets you 18. It doesn't make sense.
Wait, how would you find it with your calculator?
You type in the square root of 18 and hit enter. And magically, the calculator determines that number.
There's a square root button on the calculator.
There is a square root symbol on the calculators. Even calculators that are non-TI calculators, most have the square root as an option. Yes, ma'am? You don't need to know that yet. Okay, y'all do one, and then we'll get into some practice. I want you to please find me the best estimation for the square root of 79, please. You can find me the best estimation. You know, use that slip of paper or put it in your notes. The best estimation for the square root of 79. I want to see the work. Mental math has not been working out for you. Let's not continue.
Where's 79?
Christopher, let's go. Jonah, let's go. Square root of 79. Okay.
Oh, yeah.
By the way, this is a good reason why I would make your good square root list when you're having to do this. Now, some of you know it, like in your head, you get it. I'm sure that's the case. But if you don't, make your list of good square roots. Really, between 4 and 144 are all you need. And once you get your fraction, make it decimal. Round it to the tenth. Once you get your fraction, make it into a decimal, round it to the tenth. So I want to see it as both a fraction and a decimal rounded to the tenth. Okay, but I wrote notes and you chose not to write them. If I'm gonna take the time to write it, you need to take the time to write it. Guys, sincerely, if you're not taking notes, then I've got no sympathy for the grades. You gotta take the time to write the notes. Does anybody not have at least the fraction done yet? Okay, so let's build our fractions. What two good square roots is 79 between? Square roots of, Alex?
64.
Perfect. 64 and 81, very good. Which means our numbers between 8 and 9. So it's 8 and something. So now we simply need to find the something, right? Distance from 64 to 79. 15. What's the entire distance? 17. Therefore it's 8 and 15 17ths. 8 and 15 17ths. If I want to find the decimal, I simply do 15 divided by 17. Decimal in 3 zeros. Bring my decimal up. 17 to 150, I would say 276. Is it 8? 8, 7 is 56, 9, 10, 11, 12, 13, 8. 8 times 7 is 56. 5, 8, 9, 10, 1, 3. That's 14. Bring down my 0. It's 8 again. Oh, then I'm good enough. By the way, if you went beyond that, you didn't need to because I said round it to the tenths. In order to round to the tenths, all you need is the hundredths number so you know if the tenths guy goes up or stays where he's at. So the estimation is 8.9. 8.9. Okay? Any questions on that? Okay, one more thing and we'll get on our classwork. Put these in order. Least to greatest. Put them in order. Least to greatest.
Oh boy. I'll use this in real life.
We use it in real life. Approximating numbers. Rounding numbers. Geometry. Trigonometry. Pre-cal. Anything else there, Jace?
I would use and count in real life.
You're an engineer or an architect. I'm sorry, next. Anything else? Physicist. Physician. Architecture. Engineering. Construction. Putting a fence in your backyard. I know in your 11 years of life you have seen it all. Oh, that's right. There you have. Okay. Here we go. Least to greatest, please. Come on, let's go, let's go. Least to greatest, please. Alrighty, I just put on antibacterial. I put on my finger.
Yeah, one more time. I swear.
Boys, let's go. Okay.
I can't do this. It's so hard.
Is it? Oh, and I want to stop, and I want you to look up real quick. I need you to stop, believe. Hi, look up, and stop writing. Spin it. Stop writing and look up. Now, in math, sometimes you really just need to think, and I'll show you what I mean by that. We have 7.1 that is already a decimal. This is actually a fairly easy one because you can convert an improper fraction into a decimal. So it ends up being 5, bless you, 9 times 5. Do what? And 7 9. 5 and 7 9. So just leave it. Really, don't write. I want you to watch. I know that both this and this are between what two whole numbers? Yes. They're between 6 and 7. Guys, you don't have to do any math. So those of you that are writing, I need you to stop and just look. This is applying reason. I know both of these numbers are between the square roots of 36 and 49. Therefore, they're both between 6 and 7. Both of them. I already have my order. Because this has to be my smallest number because it's 5 and change. This has to be my biggest number because it's 7 and change. Which one of these two is smaller?
40.
Square root of 40. And I really didn't have to do any math other than convert my improper fraction. The reason I bring that up is this. Don't just go start doing math. Step back for a second and think. Think about it. Now, does that work always? No. Sometimes you're actually going to have to find an irrational square root, but not always. And in fact, most of the time, if you'll just step back a little bit and go, okay, where is square root of 40? Well, it's bigger than 6, right? But it's smaller than 7. Well, this is bigger than 7, this is smaller than 6, and this I can compare really, really easily. So don't always jump into doing the math, okay? You'll save yourself a great deal of time. Any questions on what we did today? Cool. Let me get a classwork. Get